Let's define our 6 trig functions using the right triangle. So I have a right triangle drawn here, and I'm going to label the sides A, B, and C as follows. So B is going to be the length opposite the angle theta. A is going to be the length of the side adjacent to the angle theta, and C is going to be our hypotenuse. All right, so the first one we're going to define is the cosine of theta, which is equal to the adjacent side to theta over the hypotenuse. So it's measuring the ratio of the lengths of these sides. So it's A over C. That is the adjacent side to theta over the hypotenuse. All right. The next one we're going to define is the sine of theta. And this is equal to the opposite side, so B, over the hypotenuse C. So it is the opposite over hypotenuse. And the third one is going to be the tangent of theta, and it's equal to B over A, or opposite over adjacent. So when I say opposite, I mean opposite to the side opposite of the angle theta. All right, these are our 3 most important trig functions, and they come up the most often. But each one of them has a reciprocal function associated with it. So the cosine of theta, its reciprocal, 1 over cosine of theta, we're going to call secant of theta. So it's just the reciprocal of cosine of theta, so it is C over A. Sine has 1 as well, so 1 over sine theta, we're going to call cosecant of theta, and it's equal to C over B. And lastly, cotangent of theta is reciprocal, 1 over cotangent of theta, is going to be cotangent. Oops, I messed that up right there, didn't I? Let's fix that. So 1 over tangent of theta, the reciprocal of tangent of theta, is equal to cotangent of theta. So that's equal to A over B. Great. Let's move to a new board and see how, given a right triangle, we can define or find all 6 of our trig functions. So let's say we have the following right triangle, 3, 4, and 5. And we'll call this again angle theta. So let's start with cosine of theta. So the cosine of theta, remember, is the adjacent side over the hypotenuse. So in this triangle, it is 3 over 5. The sine of theta, which is opposite over hypotenuse, would be 4 over 5. And tangent of theta, opposite over adjacent, would be 4/3. And the corresponding reciprocal functions, secant theta, would be 5 over 3. Cosecant of theta would be 5 over 4. And cotangent of theta would be 3 over 4. That's simple. Well, what if I gave you one of these ratios and asked you to find the other 5? Let's see an example where that might come up. So suppose you have a right triangle. So suppose you have a right triangle, and I'm only going to give you the ratio of 2 of the sides. So let's draw our triangle, and I know that the sine of theta is equal to 5 over 13. Can you find the remaining 5? Well, if you know the ratio of theta, or the ratio of 2 of the sides, then you can find the third side with the Pythagorean Theorem. So sine of theta equals 5 over 13 can generate a triangle whose sides, well, the opposite to theta is 5 and the hypotenuse is 13. Now there are many triangles that have this ratio, but this is one in particular. So the question is, what is this missing side, a? Well, now we employ the Pythagorean Theorem, which says a squared plus 5 squared equals 13 squared, or a squared plus 25 equals 169, or a squared equals 144. This tells us that a must be 12. Now that we know a is 12, which means we now know the sides of all of our the lengths of all of our sides of our triangle, we can define the other 5. So the cosine of theta is 12 over 13. The tangent of theta is 5 over 12. Let's talk about our reciprocal functions. Secant of theta is 13 over 12. Cotangent of theta is 12 over 5. And lastly, from our given information above, cosecant of theta is 13 over 5. And that's how we do it.